Rachel again.
Hi, Thomas is here too.
Tom's still here. So we're going to start implicit differentiation. We'll finish next class. So implicit differentiation, what it is usually we've been doing something called explicit differentiation. And that just means that, like, typically if we had ddx of, I don't know, like x cubed. So we're saying that what's the derivative of x cubed with respect to x? And that's the easy part, right? That's kind of what we've been doing with our product rule, our quotient rule, and then our chain rule. So if we go on down though, let's do a couple of these. We're at the bat, if I said what is dy dx of this, that would just be 3x to the 2, right? We've done that over and over again. If we look at this one, I'm just writing it, it's the same thing, but we're writing f of x, right? So y is equal to, instead of y, f of x at 3. So again, dy dx would be equal to 3
f of x to the square.
F of x to the 2, right? Or really 3y to the 2, same thing. Or 3x to the 2. Oh, sorry. My bad. This is where things change. So this is really saying 3 f of x. So that is the same, like I said, as 3y to the 2. But this is different than this, right? We had x's in this first one, and now we've got 3y to the 2, is what it's saying there, right? So this is where things change. What we're really going to do is the chain rule. This is the explicit differentiation part of it. So we differentiated the outside, so 3, we brought that down here, and then that becomes a 2, and now we have f of x. But now we need to take the derivative of f of x.
What is f of x?
We don't know it, so that's going to be dy dx.
So just the derivative of f of x.
Yeah. Or yeah, you could say or d f of x, something like that, right? Yeah, so that kind of brings us to our main point here. This is the type of question that we're going to get. So something that looks something like this. This could be a y or an f of x. And it says, differentiate this equation. So that's what we're going to have x's and y's involved here. But we want just one formula that we can plug in our x's and y's and figure out the slope at any point.
Yes, please.
So the way we do that is we're going to take the derivative. So ddx of the entire thing. So that means taking the derivative of 16,
Which is 0.
which is 0, right? So that we can just start filling this in. So the derivative of 16 is 0.
Equals 2x plus 2 f
Right.
of x.
And I'm going to start writing in, I'm going to draw the middle step too, so we just don't get lost here. So this is going to be ddx of 16 is equal to, and now
Sorry for the interruption. Can I get some student volunteers to deliver hotline please?
ddx of x squared, and we're used to those, right? And then plus ddx of f of x squared. But f of x, this isn't the same thing as having like an x term, right? This is really a bunch of like y's, a bunch of x's in there. This would be some kind of function, some kind of like x is locked up in there.
Yeah.
So what we need to do is, I'll just fill this out now. So if we take the derivative of 16, that was 0 like Thomas said. The derivative of this one would be just 2x and then plus. And now what we're really doing here is just a chain rule. We're going to take the derivative of the outside, so we can take ddx of, that 2 that's up there. So the 2 comes out front. I've still got f of x. And then that just becomes a 1 up top, so I'm just not going to write it. But then the next step is I need to multiply by the derivative of the inside, which would really be like,
dx and f of x?
so make sure I write this right. Yeah, let's just write it like this. F prime of x, so like the derivative of the inside. So that's pretty much it. So if we're looking for the derivative, that's this term, right, of this function, now I can rearrange this to solve for this. So if I rearrange this, that would just end up being f prime is equal to negative 2x over 2f of x, or 2y, same thing, and I'll write it more the way we more typically write it. So the derivative of f of x is equal to, actually let me rewrite that and say y prime, the derivative, is equal to negative 2x over 2y. So you can see that in these questions we're going to have, the derivative is going to have an x and a y term now when we do these. Kind of make sense? Kinda? Let's do this one. Same thing, right? It was an f of x here. Let's write it as a y. That's more typically the way we're going to see it. I just wrote it as an f of x to kind of show you the main point here. But if we did this one and we implicitly differentiated that, means we need to take the derivative of that term, and that term. So let's do that. So the derivative of 4x squared is going to be 8x. And then, is that minus? Plus. Plus. Now this one, all you ever have to do is it's the chain rule, right? So we're going to take the 2 down front. So 18, the 2 times the 9 is 18. And then the y stays the same. So 18y to the 1. And then I just need to tack on or multiply by dy dx. It's going to be like that every time. You just pretty much take the derivative like normal and then tack on dy dx to the y term. And this was all equal to 0, because 36 is, derivative of 36 is 0. So then, second step, we just need to solve for dy dx. So dy dx, if you solve for that, is equal to negative 8x over 18y. That's the idea. That's pretty much it. I'm going to end it there, just as like an intro into implicit differentiation. We'll finish these notes on Wednesday, I guess. What I would like you to do, though, just for practice from last day.
And do your physics.
And do your physics, too.
Just kidding, I love you.
Thomas is doing his physics exam today, he said. Where are we at here? Maybe. Let's go. Yeah, what I'd like you to do. Is not that. These ones. So using the chain rule, I'd like you to practice those, and just when you guys come in on Wednesday, just make sure that those are done. And assignment number 1. So these questions right here and assignment number 1. And that's it.